There is a problem in the universe so disturbing that it has kept physicists awake for nearly a century. Because when scientists measure the motion of galaxies, the math breaks badly. The stars move too fast, gravity isn't strong enough, and according to every known law of physics, galaxies should not even exist. But they do, which means one of two things must be true. Either our understanding of gravity is fundamentally wrong, or the universe is filled with an invisible form of matter we have never seen. And what scientists are discovering now may be even stranger than anyone imagined. To understand why dark matter keeps scientists awake at night, we need to begin with a very simple question. What is the universe made of? Everything you can see, the earth beneath your feet, the sun, the planets, the stars scattered across the night sky, distant galaxies spinning slowly in the dark, even your own body. All of it is made of ordinary matter, the kind of matter that emits light, reflects light, or interacts with light in some way. And because of that, we can see it, we can measure it, we can name it. But then astronomers began to notice something deeply strange. When they observed galaxies and ran their calculations, the numbers came out wrong, and not slightly wrong, completely wrong. Let me offer you an image to hold on to. Imagine tying a stone to a length of string and swinging it in a wide circle. The string holds the stone in place, but if you spin it too fast, the string isn't strong enough and the stone flies free. Galaxies work in much the same way. The stars at the outer edges of a galaxy are spinning around its center at tremendous speeds. According to the physics we know, they should have been flung out into the void long, long ago. But they haven't been. Something is holding them in place. The trouble is, no one can see what that something is. At first, scientists wondered if perhaps they had simply miscalculated. Perhaps there were more faint, undiscovered stars out there adding to the mass. Perhaps the instruments weren't sensitive enough. But the more they looked, the stranger it became. They realized that all the visible matter in the universe, every star, every planet, every cloud of gas and dust, accounts for only a small fraction of what must actually be there. Think of it this way. You're standing on a great bridge, looking down at the water below. Beneath the surface, you can only make out a few thin supports, and yet the bridge holds firm, solid, and steady, in a way that simply shouldn't be possible with so little holding it up. There must be an entire hidden framework beneath it all, something vast, something invisible, something you cannot see, but that is undeniably there. And that is the moment the idea of dark matter was born. A form of matter that emits no light, reflects no light, cannot be seen through any telescope ever built, and yet it has gravity. And that gravity, quiet, invisible, immense, is enough to hold the entire universe together, to keep it from flying apart into nothing. Scientists began to calculate just how much of this dark matter there would need to be if it truly exists. The answer left them stunned. Everything we have ever seen with our eyes, our instruments, our most powerful telescopes, every star, every world, every galaxy accounts for only around 5% of the universe. 5%. The rest is almost entirely invisible, which means we are living inside a universe whose vast majority we do not understand. We cannot see it, we cannot touch it, we can barely even begin to describe it. And yet, it is all around us, right now, in this very moment. The universe is far darker than we ever imagined. And somewhere in that darkness, the answers are waiting. But if dark matter is invisible, how do scientists know it's actually there? The answer is quietly elegant. They can't see it directly, but they can see what it does. Much like the wind, you never see the wind itself, and yet you watch the leaves tremble, the branches bend, the surface of a lake ripple outward in the stillness. You know something is moving through the world, even if you cannot name its shape. Dark matter is like that. One of the most compelling pieces of evidence comes from a phenomenon called gravitational lensing. It sounds complex, but the idea, at its heart, is rather beautiful. Einstein's theory of relativity tells us that mass, true substantial mass, can bend the fabric of space itself. Imagine placing a heavy bowling ball at the center of a mattress. The surface dips, it curves, and if you were to roll a small marble nearby, it wouldn't travel in a straight line. It would curve inward, drawn along the contours of that dip. The universe behaves in much the same way. An object of enormous mass can bend the path of light passing close to it, curving it, stretching it, warping it like a lens made of gravity itself. And when scientists trained their telescopes on distant clusters of galaxies, they noticed something they couldn't quite explain. The light was bending far more than it should, more than all the visible stars and gas and dust could possibly account for. The only explanation was that something else was there, something with enormous mass, something they simply could not see. In other words, dark matter was leaving its fingerprints on the light. Then came the computer simulations. Scientists attempted to build a virtual universe. They fed in every law of physics they knew: gravity, motion, the behavior of gas and energy, and let the machines run. Let them simulate the birth and growth of galaxies across billions of years. The result? The universe simply didn't work. Galaxies failed to form properly. Structures collapsed too quickly or scattered too widely. Everything fell into chaos. But then they added dark matter, and something remarkable happened. The galaxies formed. The great cosmic web of clusters and filaments emerged, just as we observe it today. The pieces fell into place, quietly, precisely, like the final tile completing a mosaic that had seemed impossibly incomplete. And so, the hunt for dark matter truly began. For decades, the leading theory was that dark matter consists of extraordinarily heavy particles, particles so reluctant to interact with ordinary matter that they pass through walls, through planets, through you and I, without leaving so much as a trace. Scientists called them WIMPs, weakly interacting massive particles. And to find them, They built some of the most extraordinary laboratories in human history. Not in gleaming towers or open fields, underground, deep underground, beneath kilometers of solid rock, chosen specifically to block the endless noise of cosmic radiation raining down from above. In old mines, in tunnels carved through mountains, places of profound quiet where the world above could not intrude. And there, in that deep silence, scientists waited for years, then decades, instruments of breathtaking sensitivity, listening for the faintest whisper, hoping that one day, perhaps on an unremarkable Tuesday in the middle of the night, a single dark matter particle would brush against a detector. Just once, just enough to leave the smallest trace, a single signal. That would have been enough to rewrite the history of physics. But the years passed, and the detectors remained silent. No signal came, no trace, no whisper, nothing. And perhaps that silence is the most unsettling discovery of all, because it means that whatever dark matter is, it is stranger than we imagined, more elusive, more mysterious, more patient than we are. It has been here since the earliest moments of the universe, holding everything together, asking nothing and revealing nothing. At least, not yet. After decades of searching and finding nothing, a quiet question began to stir. What if we have been looking for the wrong thing all along? For years, scientists assumed dark matter was made of heavy particles, dense, solid, substantial, the kind of thing a detector might catch if only it was sensitive enough. But what if that assumption was wrong? What if dark matter isn't heavy at all? What if it is almost impossibly light, millions of times lighter than any particle we have ever known? Something that light would not behave like a particle at all. It wouldn't drift through space like a grain of dust or a pebble or a slow-moving stone. It would behave more like an ocean, an invisible ocean of waves, vast, silent, and endlessly moving, washing through everything, through the walls of this room, through the ground beneath you, through your own body in this very moment as you listen to these words, and you would never feel a thing. That idea, strange as it sounds, is being taken very seriously today by scientists, because if dark matter truly is wave-like in nature, then perhaps we have been building the wrong instruments entirely, listening for a knock on the door when we should have been listening for a tide. And here is where things become stranger still. Some researchers now believe that we may not need to venture into deep space to find dark matter. We may not need underground laboratories or decades of patient waiting, because dark matter, if it behaves like waves, might already be detectable far closer to home, right above our heads, in the upper layers of Earth's own atmosphere, quietly present, quietly waiting, as it has always been. High above the Earth, far beyond the clouds, far beyond the reach of any weather, there is a layer of the atmosphere unlike anything below it. It is called the ionosphere. Up there, radiation streaming from the sun strips electrons from atoms, leaving them electrically charged, restless, alive with energy. You might imagine it as a vast, shimmering ocean, not of water, but of charged particles, endlessly moving, endlessly resonating. And this is where the story takes a quietly extraordinary turn. If ultralight dark matter truly exists as waves, then as those waves pass through the ionosphere, they may cause the charged particles there to oscillate, to vibrate, to move in perfect time with the rhythm of the dark matter itself. Scientists call this resonance. It is the same principle as a singer holding a single pure note and watching a crystal glass begin to tremble across the room. The glass isn't touched, no force is applied directly, and yet it responds because the frequency is exactly right. Or think of a child on a swing. If you push at just the right moment, again and again, the swing rises higher and higher, not because of any great force, but because of perfect timing. If that resonance occurs in the ionosphere, it may produce something remarkable, a faint radio signal, quiet as a whisper, easy to miss entirely, but not impossible to find. And that possibility opens a door that no one had previously considered. Instead of building vast detectors deep beneath mountains, instead of waiting in underground silence for decades, we might simply listen. Using sensitive radio antennae pointed not downward into the earth, but upward into the sky. Listening for dark matter the way you might press your ear to a wall and hear, very faintly, a sound you cannot quite explain. It sounds perhaps like science fiction, but the universe has a long history of hiding its secrets in radio signals. In 1967, a young researcher named Jocelyn Bell noticed something unusual in her data, a radio signal, repeating with extraordinary regularity, so precise, so rhythmic, that for a brief and rather wonderful moment, some scientists dared to wonder, could this be a message? Could something, somewhere, be trying to reach us? It turned out to be a pulsar, a neutron star spinning at extraordinary speed, sweeping a beam of radio waves across the cosmos like a lighthouse in the dark. No message, no intelligence behind it, and yet a discovery that changed our understanding of the universe entirely. The cosmos, it seems, is always speaking. We simply have to learn which frequencies to tune into. And perhaps dark matter is no different. Some of the theories being considered today are stranger still. Stephen Hawking, one of the most brilliant minds of the last century, once proposed that in the first fractions of a second after the Big Bang, the universe may have been so violent, so compressed, so unimaginably energetic that tiny black holes formed spontaneously throughout the newborn cosmos. Not the great black holes born from collapsing stars, but primordial black holes, ancient beyond reckoning, some perhaps no larger than an atom. And some scientists believe these primordial black holes may be connected to dark matter. Many would have evaporated long ago, dissolving slowly into radiation over billions of years, but their gravitational echoes, the subtle fingerprints they left on the fabric of space, may still be detectable if we know where to look. What is remarkable about all of this is that none of it is speculation for its own sake. Every one of these ideas, the wave-like particles, the resonance in the ionosphere, the primordial black holes, is being studied seriously right now by some of the sharpest minds on Earth. Because the honest truth is, after all this time, after all these decades of searching, no one truly knows what dark matter is. We know it is there. We can feel its gravity. We can see its influence written across the entire structure of the universe. But its nature remains for now beyond us, a mystery so large it surrounds everything we have ever known. And perhaps that is not a discouraging thought. Perhaps it is an invitation. The universe is telling us quietly and patiently that there is still so much left to discover, that the greatest chapter of the story has not yet been written. Perhaps right now, billions of dark matter particles are passing through you, through your hands, through your chest, through the quiet space behind your eyes, every second, silently, without trace. Perhaps our entire galaxy is drifting slowly through an enormous cloud of it, invisible, immense, ancient beyond reckoning. And perhaps everything we call the universe is only the surface of something far deeper. The most extraordinary thing isn't that we haven't found the answer yet, it's that we keep looking. From great telescopes turning slowly in the dark of space, to laboratories buried deep beneath mountains, to the very atmosphere above our heads. Every new theory opens a door. And one day, perhaps not with a great explosion, not with lights and fanfare, but with something very small and very quiet, a faint radio signal, barely there, the universe may finally whisper back, telling us at last that what we always suspected is real.